Hi guys, imagine a night where the sky isn't just a sky, but a giant canvas painted with secrets, mysteries, and glowing fires that never die. You look up and thousands of stars are scattered above you, like diamonds thrown into an endless ocean. Now think for a second when there was no electricity, no smartphones, no telescopes, no satellites. How did people see this sky? What did they think when they looked up at these stars? Were they just lights, or were they messages from the gods, signs of destiny, a cosmic map for their lives? This is the story of ancient astronomers, the first dreamers who dared to look up and ask questions. Tonight, I'm taking you back thousands of years into the deserts, jungles, rivers, and temples where humans first began to understand the universe. So dim the lights, open your imagination, and let's travel to the beginning of stargazing. It starts in Mesopotamia, the land between the rivers Tigris and Euphrates, often called the cradle of civilization. Imagine standing on the dry plains of Babylon 4,000 years ago. There are no skyscrapers, no artificial lights, only fire torches flickering, and above them, the clearest, brightest night sky you could ever see. For the Babylonians, the stars were not random. They were patterns, messages, and even gods. They believed their fates were written in the skies. Priests would climb tall ziggurats, these massive step-like temples, just to get closer to the heavens. They recorded the movements of the moon, Venus, and Mars on clay tablets. Some of those tablets still survive today, telling us how carefully they mapped the skies. They weren't just looking for beauty. They were searching for order, for signs, for a way to predict floods, seasons, even wars. In a way, they were the first weather forecasters, the first calendars, the first scientists of the night. Now picture this, a Babylonian priest standing on top of a ziggurat at midnight. He raises his hands toward the stars and whispers prayers. He believes Jupiter is the king of the gods, Saturn, the bringer of omens, Venus, the goddess of love and war. Every planet, every star, every comet was a divine sign, and the people below believed him because the stars did move in patterns. When Venus rose before sunrise, it always meant change. When eclipses darkened the sun, fear spread through entire cities. The Babylonians turned the sky into a living text, a holy book written in shining dots. Their knowledge grew so advanced that they could predict eclipses centuries in advance. They invented the zodiac, the same zodiac signs people still follow today. Aries, Taurus, Gemini, Cancer. These were born in Mesopotamia. But in their time, these weren't just fun horoscopes. They were serious, powerful tools used to decide the fate of kings, battles, and empires. Think about that. Every time you see a zodiac chart online, you're re-looking at an echo of something that began thousands of years ago under the skies of Babylon. But Babylon was not the only place where people watched the heavens. Travel west to the banks of the Nile River, to ancient Egypt. Here the stars ruled not only faith, but survival. Every year, the Nile flooded its banks, leaving behind rich soil that made farming possible. But the flood was unpredictableness. You knew where to look. The Egyptians discovered that the rising of a particular star, Sirius, always came just before the annual flood. To them, Sirius wasn't just a star, it was the goddess Isis, bringing life back to the land. By watching Sirius, they could predict the flood, plant their crops, and feed their people. In other words, astronomy saved Egypt. And think about the pyramids. Those giant stone mountains, built with unimaginable precision, weren't just tombs for pharaohs. They were aligned with the stars. To them, the journey to the afterlife was a journey through the stars. The shafts inside the pyramids weren't random tunnels, they pointed toward specific stars, guiding the soul of the king to eternity. Imagine lying inside that dark chamber, knowing above you the stones align with the heavens. It's chilling, it's beautiful, it's cosmic. Egyptian temples, too, were aligned with the sky. At Karnak, one of the largest temple complexes in the world, the axis of the temple aligns with the rising of the midwinter sun. At Abu Simbel, the temple of Ramses II, sunlight enters the inner sanctuary only twice a year, on the king's birthday and coronation day. Imagine the shock and awe of people standing there, watching light pierce the darkness exactly on those sacred dates. That wasn't coincidence, it was astronomy carved into stone. But here's the question: why were ancient people so obsessed with the stars? Was it religion, science, or survival? Maybe all three. For the Egyptians, stars meant gods and crops. For the Babylonians, stars meant destiny and kingship. For others, they were maps in the sky. Because, in a world without GPS, without compasses, sailors learned to travel by the stars. The North Star, steady and unchanging, became the ultimate guide through unknown seas. To watch the stars was not a hobby, it was life itself. Now let's take a step into the Indus Valley, one of the oldest civilizations in South Asia. The records are scarce, but the ruins whisper stories. Cities like Mohenjo-daro and Harappa were built with such precision that some scholars believe they followed astronomical alignments. Bathing pools, ceremonial sites, perhaps even their entire city gridsome suggest they mirrored constellations. While their writings remain undeciphered, one thing is clear: the people of the Indus Valley lived under the same sky. And like their neighbors, they must have looked up, searching for meaning in the endless black canvas. Cross the oceans now, deep into the jungles of Central America, where the Maya civilization rose. These people were masters of the heavens. Their temples weren't just places of worship, they were observatories. At Chichen Itza, for example, the Great Pyramid called El Castillo is designed so that on the equinox, the sunlight creates the illusion of a serpent crawling down the stairs. That serpent is Kukulkan, the feathered serpent god, returning from the heavens. The Maya tracked Venus with stunning accuracy, predicting its cycles better than even the Europeans of later centuries. They believed Venus controlled war and peace. Their calendar, one of the most advanced of the ancient world, was based on solar and lunar movements. And for them, time itself was cosmic. To live, to breathe, to diet was all written in the dance of the stars. Think about their calendar, the famous long count. It stretched across thousands of years, connecting human life to cosmic cycles. To them, history wasn't random. It was cyclical, repeating, turning like the stars. Imagine standing in a Mayan temple, watching priests dressed in feathers and paint, chanting as they point to the rising sun, declaring the beginning of a new cycle. For the Maya, astronomy wasn't just science. It was destiny, spirituality, and power combined. Meanwhile, far to the east, in China, astronomers were carefully recording the skies too. Chinese records mention eclipses as far back as 2000 BCE. They believed that when the sun was eaten by a dragon, eclipse it was a sign that the emperor's power was at risk. Astronomers were tasked with predicting these events, because if they failed, the emperor might lose trust, and sometimes their lives. But their work gave us some of the oldest star charts in history, with constellations still recognizable today. Chinese astronomers mapped over 1,000 stars, divided into constellations that didn't always match the Greek ones, but told their own stories. They tracked comets, novae, and even supernovae, like the famous one in 1054, which created the Crab Nebula, still visible in the sky today. Their careful notes allow modern astronomers to confirm cosmic events across millennia. Think about that. A star exploded almost 1,000 years ago, and we know about it because Chinese astronomers wrote it down. Everywhere on Earth, humans were united by one thing: looking up. Different languages, different gods, different lands, but the same stars. A farmer in Egypt, a priest in Babylon, a Mayan king, a Chinese emperor, they all looked at the same sky. They all wondered what it meant. The stars were humanity's first global connection, the one thing every civilization shared. And yet the story gets even deeper. The stars didn't just shape religion or farming, they shaped identity. Constellations were like cosmic stories, myths written above us. Orion, the hunter; Ursa Major, the Great Bear; the Pleiades, the Seven Sisters. Every culture told these stories differently, but they all told them. Why? Because humans are storytellers. We don't just see dots, we see patterns, heroes, monsters, gods. The sky became our first book, our first movie screen, our first dream. Now imagine yourself as one of those ancient astronomers. You stand barefoot on the cold stone of a temple, your eyes fixed on the horizon. The night is silent except for the wind. You watch as a star rises, slow, steady, glowing. You mark it on your chart. You know that tomorrow it will rise just a little earlier. You track it again, again, again. Days turn into years, years into lifetimes. And slowly, a truth reveals itself. The heavens move with order. There is a rhythm, a cycle, a pattern. And in that discovery, you feel something cosmic. You feel that the universe is speaking to you. That moment when humans first understood the patterns of the stars was the birth of science. It was the birth of timekeeping, navigation, calendars, predictions. It was the beginning of our journey to the stars. Ancient astronomers didn't have rockets or satellites, but they had patience, curiosity, and vision. They dared to look up when others looked down. And as we dive deeper into their world, we begin to realize watching the stars was never just about survival. It was about wonder, about connection, about the eternal human question: where do we come from, and where are we going? And maybe, just maybe, when you look up at the night sky tonight, you'll feel the same awe they once felt, because those same stars still shine. The same Orion, the same Pleiades, the same Sirius that rose over the Nile, the same Venus that guided the Maya, the same Jupiter worshipped in Babylon. They're still there. The stars are timeless. They watched over our ancestors, and now they watch over us. When Greek thinkers turned their eyes to the heavens, they didn't just see gods, they saw a puzzle to be solved. The Greeks were dreamers and debaters, and for them, the stars were not only signs, but clues to how the universe worked. Imagine a philosopher like Thales of Miletus, standing by the sea in the 6th century BCE, telling his students that eclipses weren't tea curses or dragons, but natural events that could actually be predicted. For the first time in history, someone dared to say that the heavens followed rules, not whims of angry gods. That was revolutionary. Then came Pythagoras, a man obsessed with numbers, harmony, and music. He believed the universe itself was built on mathematical patterns, a cosmic symphony where the planets moved like instruments in tune. He called it the music of the spheres. His followers imagined the cosmos as a grand orchestra, invisible notes guiding the stars across the night. Even though they couldn't prove it, the idea that math and cosmos were linked became a seed that grew into all future astronomy. And then there was Plato, who looked up and saw perfection. For Plato, the heavens were eternal, pure, unchanging. The stars moved in circles, the most perfect of all shapes. To him, understanding the heavens was a way to touch divine truth. His student, Aristotle, took it further. He imagined the universe as a series of crystal spheres, each carrying the planets and stars in their fixed paths around Earth. At the center, unmoving, was our world, with the heavens revolving around it like gears in a machine. Aristotle's vision dominated for centuries, shaping how humanity imagined the cosmos. But not everyone agreed. There was Hipparchus, a genius of the 2nd century BCE. He created one of the first star catalogs, mapping hundreds of stars with precision. He discovered the precession of the equinoxes, the slow wobble of Earth's axis over centuries. Imagine that. With nothing but his eyes and simple instruments, he realized that the heavens themselves shifted slowly over time. He even estimated the distance to the moon, shockingly close to the true value. His work was so advanced that later astronomers still leaned on his discoveries. And then, in the great city of Alexandria, with its towering lighthouse and legendary library, knowledge of the heavens was gathered from across the world. Imagine walking into that library, scrolls from Egypt, Babylon, Greece, India, stored under one roof, the first great attempt at a universal encyclopedia of human knowledge. Among those scholars was Claudius Ptolemy, who lived in the 2nd century CE. Ptolemy wrote the Almagest, a monumental book that described the geocentric model of the universe. Earth at the center, planets and stars revolving in complex circles called epicycles. For centuries, this was the Bible of astronomy. Even though we now know it was wrong, it gave structure to the chaos of the skies and dominated thought for nearly 1,500 years. But what makes this fascinating is not just the brilliance of these individuals, it's the transmission of knowledge. After the fall of Rome, much of Europe sank into what's often called the Dark Ages. Libraries burned, scrolls were lost, and much ancient knowledge risked disappearing forever. But it didn't vanish. It traveled east. It crossed deserts and seas, carried by traders, scholars, and conquerors. And in the cities of the Islamic Golden Age, it bloomed again. Picture Baghdad in the 9th century, a thriving city filled with scholars from many lands. Here stood the House of Wisdom, a vast center of learning where Greek, Persian, Indian, and Babylonian texts were translated into Arabic. Imagine translators hunched over ancient scrolls, carefully copying the words of Aristotle, Ptolemy, and Euclid into a new language, preserving them for the future. But they didn't just preserve, they improved. One of the shining stars of this era was Al-Khwarizmi, whose name gave us the word algorithm. He brought Indian numerals into the Islamic world, the same numbers we use today. His work in mathematics was vital for astronomy, because without numbers, the heavens can't be measured. Then there was Al-Battani, who refined Ptolemy's measurements and gave us more accurate values for the length of the year and the tilt of Earth's axis. His tables of star positions guided sailors and scientists for centuries. In the city of Spain, scholars like Maslama al-Madridi studied astronomy and translated works into Latin, which would later fuel Europe's own Renaissance. Imagine mosques and observatories lit by oil lamps at night, scholars peering through simple instruments, tracing the movements of the moon and stars. The call to prayer itself depended on astronomy. The position of the sun determined the times. So, astronomy wasn't just science, it was woven into daily life. Then came Ibn al-Haytham, also known as Alhazen, who revolutionized how we see. He studied optics, light, and vision, proving that we don't shoot rays from our eyes, but rather receive light into them. Without his work, telescopes would never have been possible. Imagine him sitting late at night, experimenting with lenses, mirrors, and dark chambers, laying the foundation for the instruments that centuries later would open up the universe. But perhaps the most dramatic figure was Ulugh Beg, a Timurid prince in Samarkand in the 15th century. Instead of building palaces or waging wars, he built one of the greatest observatories of the medieval world. His gigantic sextant, carved into stone, was so precise that he measured the length of a year with an error of only 25 seconds. He and his team catalogued thousands of stars, rivaling Hipparchus himself. Imagine standing in that observatory, its massive arches stretching into the sky, the hum of scholars at work, the silence broken only by the scratch of quills on parchment, as stars were recorded one by one. The work of these Islamic astronomers didn't stay in the East. Through trade, conquest, and translation, it flowed back into Europe. In places like Toledo, translators converted Arabic texts into Latin, making them accessible to scholars in Paris, Bologna, and Oxford. Suddenly, Europe had access to centuries of preserved and enhanced knowledge. The seeds of the Renaissance were being planted quietly through these translations. Meanwhile, in India, astronomers like Aryabhata and Brahmagupta were making their own breakthroughs. Aryabhata, in the 5th century, proposed that Earth rotates on its axis, a bold idea far ahead of his time. Brahmagupta developed methods for calculating planetary positions and eclipses with stunning accuracy. These works, too, traveled into the Islamic world, blending with Greek and Arabic thought, creating a fusion of knowledge that spanned continents. Think about that for a moment. The story of astronomy isn't the story of one civilization, one genius, or one moment. It's a chain stretching across centuries and cultures. Babylon to Greece, Greece to Baghdad, Baghdad to Paris. Each link carrying not just facts, but dreams, questions, and the human urge to understand. Now imagine being a scholar in medieval Europe, sitting in a cold stone room by candlelight, opening a translated copy of Ptolemy's Almagest for the first time, the strange words of Aristotle and Albatani whispering across centuries. You feel the thrill of discovery, realizing you are part of something much larger, conversation across time, carried by stars. But Europe was about to do something shocking. Instead of just preserving and respecting the ancients, some dared to question them. Nicolaus Copernicus, in the 16th century, read Ptolemy and Albatani, studied translations from Arabic and Greek, and then wrote something that turned the world upside down. The sun, not Earth, is at the center of the universe. It was the dawn of a revolution, a spark lit by ancient astronomers, but fanned into flames by new thinkers. Before we reach that turning point, though, let's pause to imagine the world just before the Renaissance. The Islamic Golden Age was fading. Mongol invasions had shattered cities, and yet the knowledge survived. In European monasteries and universities, the old texts were copied again and again. In Italy, scholars rediscovered Greek writings preserved by Arabs. In Spain, the blend of Muslim, Christian, and Jewish scholars created a melting pot of thought. Everywhere, the stars still shone above, constant, patient, eternal. And it's incredible to think when an Arab astronomer in Baghdad traced the orbit of Mars, when a Mayan priest in the jungle followed Venus, when a Greek philosopher in Athens argued about spheres, they never imagined that their work would someday guide a scientist building rockets or a telescope peering into galaxies billions of light years away. Yet, without them, none of it would exist. The story of astronomy is the story of humanity itself, always looking up, always asking, always connecting the dots, even when we had only naked eyes and crude instruments. From ziggurats to pyramids, from jungle temples to desert observatories, from scrolls to manuscripts, from Arabic script to Latin pages, it's a chain of curiosity, unbroken and unending. And as the 15th century ended, that chain was ready to blaze into something new, something bold, something dangerous. Europe would take the torch of ancient and Islamic astronomy and set it alight in a revolution of science. A revolution that would challenge everything people believed about Earth, heavens, and humanity's place in the cosmos. Imagine Europe in the 16th century, where cathedrals stretched like mountains of stone, where priests and kings ruled with iron words, and where the sky was still believed to spin around a motionless earth. The heavens were fixed, perfect, ordained by God, or so everyone was told. But in the quiet corners of monasteries and observatories, whispers were growing louder. Whispers that the ancients might have been wrong. Whispers that Earth was not the center of the cosmos, but just another traveler in the endless sea of stars. Nicolaus Copernicus, a Polish priest and scholar, sat at his desk with candlelight flickering across parchment. For decades, he had studied the movements of planets. Ptolemy's model worked. Yes, it explained the heavens with circles upon circles, epicycles upon epicycles. But Copernicus felt the weight of its complexity. Nature, he believed, must be simpler. He asked himself, what if Earth was not at the center? What if the sun was? Slowly, carefully, he developed a new model, heliocentrism. Earth spinning on its axis, orbiting the sun. Planets moving not in perfect circles, but in a grand harmony. Yet he hesitated. For years, he kept his ideas hidden, fearing the storm they might unleash. Only near the end of his life, in 1543, did his book on the revolutions of the celestial spheres see the light of day. Imagine the moment, the book placed in his hands as he lay dying, the pages filled with a vision that would change everything. Few noticed at first, but the spark was lit, and soon it would ignite a fire that could not be contained. From that spark came Johannes Kepler, a German mathematician with a restless mind. Kepler was obsessed with patterns, with harmony, with the belief that God's design could be found in numbers. For years, he tried to fit planetary orbits into circles, convinced that perfection demanded it, but the data refused to agree. Working with the painstaking observations of Tycho Brahe, the eccentric Danish nobleman who built one of the greatest observatories of his time, Kepler wrestled with the heavens. And then, the breakthrough. The planets did not move in circles at all. They moved in ellipses, stretched paths around the sun. That discovery shattered centuries of belief. Kepler's 3 laws of planetary motion revealed the clockwork of the solar system. Planets swept equal areas in equal times. Their speeds varied with their distances from the sun. The farther out they were, the longer their orbits. The heavens were no longer divine perfection, they were mathematics in motion. Kepler himself was astonished. He had dreamed of cosmic music, and instead he found the cold, precise rhythm of geometry. But he also realized something breathtaking. The universe was knowable. It was not chaos or whim, but order written in invisible lines across the sky. And then came Galileo Galilei, the man who dared to look through a new invention, the telescope. It was a simple device, just lenses in a tube, but in Galileo's hands it became a weapon against ignorance. Pointing it at the moon, he saw craters and mountains, shattering the belief that celestial bodies were perfect spheres. Turning it to Jupiter, he discovered 4 tiny moons circling the giant planet worlds, orbiting not Earth, but another planet entirely. He looked at Venus and saw its phases, proof that it circled the sun, not Earth. He even observed sunspots moving across the solar surface, revealing that the sun itself was not eternal and unchanging, but dynamic, restless, alive. Galileo wrote his findings with passion, his words sharp and undeniable. But the Church was not pleased. The heavens, they said, were God's design, and Earth was his chosen center. Galileo's telescope threatened that divine order. Summoned before the Inquisition, Galileo was forced to recant, to whisper that Earth stood still even as he knew it moved. But legend says, as he rose from the trial, he muttered, "E per se muove," and yet it moves. Whether he truly said it or not, the words captured the defiance of science against dogma. Kepler's ellipses and Galileo's telescope together built a foundation. But the one who would bind it all into a single vision of the universe was Isaac Newton. Born in 1642, the year Galileo died, Newton grew up in a world still wrestling with the old and the new. In the plague years, he retreated to the countryside, where legend says he watched an apple fall from a tree. From that simple sight, his mind leaped to the heavens. If gravity pulls the apple down, could it not also pull the moon? Newton's genius was not in seeing what others had not, but in connecting what seemed separate. The same force that made apples fall kept planets in orbit. Gravity was universal. His laws of motion and universal gravitation united the cosmos into a single system. Suddenly, everything made sense. Kepler's ellipses, Galileo's observations, even the tides of the ocean. The universe was no longer a mystery. It was a grand machine, elegant and precise, set in motion by laws that could be written in mathematics. Imagine the awe of Newton's contemporaries. For the first time, humanity had a formula that could predict the movement of planets, the swing of a pendulum, the flight of a cannonball. The cosmos was not ruled by capricious gods, but by numbers and forces that never wavered. It was terrifying and liberating all at once. Terrifying because it stripped the heavens of divine mystery. Liberating because it gave humans the power to understand and even control. But Newton himself, as brilliant as he was, did not see it as pure science. For him, uncovering the laws of the universe was uncovering the mind of God. He was both scientist and mystic, a man of equations and alchemy, of telescopes and prophecy. Yet his Principia Mathematica, published in 1687, became the cornerstone of modern physics, a book so influential that it redefined what it meant to study nature. With Newton, the scientific revolution reached its peak. The world was no longer flat, no longer centered on Earth, no longer mysterious beyond reason. It was a universe governed by laws, waiting to be uncovered. From Copernicus's hesitant whisper to Kepler's ellipses, from Galileo's telescope to Newton's equations, humanity had leaped further in a century than in millennia before. But this revolution was not just about knowledge, it was about power. With astronomy came navigation, and with navigation came exploration and conquest. European ships sailed across oceans, guided by the stars and by increasingly precise charts. Empires rose on the back of astronomy, for to know the heavens was to master the seas. The same knowledge that mapped the planets also mapped the globe. Think of the sailors on vast wooden ships, steering by Polaris, calculating their latitude with sextants, trusting in the work of astronomers back home. The age of discovery was powered by the same science that challenged the church. The stars that once told farmers when to plant now guided explorers into unknown worlds. Astronomy was no longer only about wonder, it was about survival, wealth, and dominance. And yet, through all this, the deeper truth remained. Every discovery raised new questions. Newton explained gravity, but what was it really? How could it act across empty space? Copernicus moved Earth around the sun, but what lay beyond the stars? Galileo revealed moons and craters, but were there other worlds, perhaps inhabited, circling distant suns? The revolution solved old mysteries, but also opened doors to new ones. In the quiet hours of night, scholars still gazed upward, not as conquerors, but as dreamers. Imagine a 17th century astronomer in a dark observatory, the flicker of oil lamps casting shadows on the walls, carefully adjusting lenses, sketching the moon, feeling the vastness of the universe pressing down. The discoveries were monumental, but the awe was the same as it had been for the Babylonian priest, the Egyptian farmer, the Mayan priest king. The stars still whispered the same question: what lies beyond? This was the age where astronomy shifted forever from myth to science, from stories to equations. Humanity had taken the first great leap outward, breaking the chains of old belief, daring to say that the cosmos could be understood. And in doing so, we placed ourselves not at the center, but as travelers on a small planet circling a star in a universe far larger than anyone had ever imagined. Yet, even in triumph, the revolution carried shadows. Galileo's trial was a warning. Knowledge had consequences. To challenge the heavens was to challenge power itself. Copernicus published only at death. Kepler worked in poverty, often hunted for his religious views. Newton himself was secretive, fearful of ridicule, reluctant to share his deepest ideas. The revolution was not a peaceful dawn, but a storm, filled with danger, courage, and sacrifice. And still, the storm cleared. The telescope spread across Europe, improved by craftsmen and scientists. Star maps became more precise. Comets were no longer omens, but calculable visitors. Eclipses were predicted to the minute. The heavens were becoming less frightening, more familiar, more human. For the first time, people could believe that the universe was not beyond them but within reach. That belief would carry humanity into the next chapter, where telescopes grew larger, where stars were measured and catalogued by the thousands, where distant galaxies would be discovered, and where the faint whispers of starlight would tell the story of the universe itself. But that is a story for another part. For now, picture this: Newton closing his manuscript, Kepler tracing his ellipses, Galileo polishing his telescope lens, Copernicus staring at the heavens from a quiet Polish town. Four men separated by decades, united by one vision that the universe could be understood, not by faith alone, not by fear, but by the daring act of looking up and asking why. And because of them, we stepped out of the shadows of myth and into the light of science. The centuries after Newton carried the momentum of revolution forward. Astronomers no longer looked at the heavens merely with naked eyes, but with ever-improving instruments, glass lenses, stretching human vision into realms never imagined. William Herschel, a German-born musician turned astronomer in England, built telescopes so massive they seemed like cannons aimed at eternity. One night in 1781, peering through his lens, he saw a faint dot moving slowly against the stars. It was not a star at all, it was a new planet. Uranus, the first planet discovered in modern history, revealed that the solar system was not a closed set of 7 wandering lights, but larger, more mysterious than anyone knew. Herschel went further, cataloging thousands of stars, and discovering that some came in pairs, locked together by gravity. For the first time, humans realized the universe was filled with binary systems, stars dancing in cosmic duets. He also noticed faint smudges of light scattered across the sky, some of which he suspected might be island universes, entire galaxies beyond our own. At the same time, on Earth, clocks and mathematics advanced. The precision of pendulum clocks allowed astronomers to measure time with extraordinary accuracy, which meant the movement of stars could be tracked more precisely than ever. Observatories became symbols of power, built by kings and nations, equipped with domes, gears, and instruments of brass and steel. Astronomy was no longer just the domain of lone dreamers. It was an institution, a discipline, a science marching into modernity. Yet, as telescopes reached further, they revealed a cosmos stranger than expected. In the 19th century, spectroscopy allowed scientists to break starlight into colors, like rainbows etched into glass. With this tool, astronomers learned that stars were not just points of light, but burning spheres of gas, their chemical fingerprints written in their light. Hydrogen, helium, carbon. Suddenly, the stars were not distant mysteries, but kin to our own sun, governed by the same elements found on Earth. The universe, vast as it was, seemed made of the same fabric as us. Meanwhile, new planets continued to reveal themselves. Neptune was discovered not by telescope alone, but by mathematics. Tiny deviations in Uranus's orbit hinted at another unseen body tugging at it. Mathematicians predicted where it must be, and when astronomers pointed their telescopes, there it was. For the first time, humans had found a planet with equations before they had ever seen it. The marriage of theory and observation was complete. But even as the solar system expanded, the question grew louder. What lies beyond? Herschel's nebulae still lingered as smudges, unresolved mysteries. Some believed they were gas clouds within our galaxy. Others suspected they were entire galaxies themselves, unimaginably far away. The debate raged, a cosmic argument stretching into the 20th century. And then came Albert Einstein, a quiet patent clerk in Switzerland, who in 1905 wrote equations that bent the universe. His theory of relativity shattered Newton's clockwork certainty, showing that space and time themselves were not rigid but flexible, curved by mass and energy. Suddenly, gravity was no longer a mysterious force pulling across empty space. It was the warping of space-time itself. The sun bent the space around it, and planets rolled along those curves. Even light, the fastest thing in the universe, could be bent by gravity. Einstein's vision seemed almost too radical, but in 1919, during a solar eclipse, astronomers tested it. They measured the apparent position of stars near the sun, and, as predicted, their light was bent. Overnight, Einstein became a global celebrity, his wild-haired face a symbol of a universe stranger than anyone had imagined. Relativity didn't just describe planets, it predicted black holes, collapsed stars so dense that not even light could escape. It predicted that the universe itself might not be static, but expanding. Enter Edwin Hubble, an American astronomer at Mount Wilson Observatory in California. Using the giant Hooker telescope, the largest in the world at the time, he studied those faint nebulae Herschel had noticed. In the 1920s, Hubble proved that one of them, the Andromeda Nebula, was not inside our Milky Way, but an entire galaxy of its own, millions of light-years away. The universe was not a single island galaxy, it was an ocean filled with billions of galaxies. And then he went further. By measuring the redshift of their light, he showed that galaxies were rushing away from us, the universe itself expanding in all directions. This was the birth of modern cosmology, the beginning of the idea of the Big Bang. Imagine the shock. For millennia, humans believed the universe was eternal and unchanging. Then Newton showed it was a machine. Einstein bent that machine into curves of space and time, and Hubble revealed that the entire machine itself was stretching, expanding, alive. The cosmos was no longer a stage, it was an actor in its own story. As the 20th century unfolded, astronomy merged with technology in unprecedented ways. Radio astronomy allowed scientists to hear the universe, tuning in to signals invisible to the eye. Radar measured the distances to planets with pinpoint accuracy. During World War II, military technology spilled into science, and soon the Cold War pushed astronomy even further. Rockets, built first for weapons, became tools for exploration. The space age had begun. In 1957, the Soviet Union launched Sputnik, a tiny beeping sphere, the first artificial satellite. Suddenly, humanity was not just watching the stars, we were joining them. A few years later, Yuri Gagarin became the first human to orbit Earth, his voice carried across the void. Then, in 1969, Neil Armstrong set foot on the moon, whispering words that echoed across history. One small step for man, one giant leap for mankind. For the first time, humans stood on another world, looking back at Earth as a fragile blue sphere hanging in blackness. That image changed us forever. But exploration didn't stop with footsteps. Space telescopes lifted our eyes beyond Earth's blurry atmosphere. The Hubble Space Telescope, launched in 1990, revealed galaxies by the thousands, stretching billions of light-years away. Its deep-field images showed that even the darkest patches of sky were crowded with galaxies, each with billions of stars. It was overwhelming. Our place in the cosmos was smaller and yet more magnificent than ever imagined. And the mysteries deepened. Black holes, once a mathematical curiosity, became real as astronomers detected their gravitational pull on nearby stars. Quasars, brilliant beacons at the edges of the universe, turned out to be powered by supermassive black holes, devouring matter at their centers. The universe was stranger, more violent, more dynamic than the ancients had ever dreamed. In 1965, two scientists accidentally discovered a faint hiss of static in their radio antenna. That static turned out to be the afterglow of the Big Bang itself, cosmic microwave background radiation, the echo of creation. For the first time, humanity could hear the birth cry of the universe, a faint whisper from 13.8 billion years ago. Meanwhile, theories grew bolder. If the universe had a beginning, might it also have an end? Would it expand forever, or collapse back into itself? Dark matter was proposed to explain why galaxies spun faster than visible mass allowed. Dark energy, even more mysterious, was discovered in the late 1990s, pushing the expansion of the universe to accelerate. Suddenly, most of the cosmos was unknown, invisible, beyond comprehension. The stars we see are just the surface of a much deeper mystery. Yet even as the questions grew, so did our reach. Probes like Voyager left Earth, carrying golden records of human music and voices, drifting into interstellar space. Mars rovers rolled across red deserts, sending back images of alien horizons. Telescopes like Kepler and now James Webb began scanning distant stars for exoplanets, worlds orbiting suns light years away. For the first time, we found planets in the thousands, some rocky, some gas giants, some in the so-called habitable zone where liquid water could exist. Suddenly, the question, "Are we alone?" no longer sounded like fantasy, but like a scientific challenge awaiting an answer. Einstein's theories continued to prove themselves. In 2015, scientists detected gravitational waves ripples in spacetime caused by colliding black holes. It was as if the universe itself rang like a bell, and we could finally hear its vibrations. A few years later, astronomers captured the first image of a black hole's shadow in the galaxy M87, a glowing ring of light bent by gravity around a dark abyss. What had once been imagination was now photograph. And yet, through all this progress, one truth remained. The sky still humbles us, just as Babylonian priests once raised their hands to Jupiter, just as Mayan astronomers tracked Venus, just as Galileo whispered about moving Earth. We still stand under the same stars with awe. Technology has sharpened our vision, but the feeling is unchanged. Wonder, curiosity, the ache of mystery. Today, our telescopes peer not only across distance, but across time. Every photon of starlight is a time capsule. To look at a nearby star is to see it as it was years ago. To look at a distant galaxy is to see it as it was millions, even billions of years ago. The universe is a museum of light, and every night we walk its halls. And where do we go from here? Missions are planned to Mars, to Europa, to Titan. Telescopes are being built that will study the atmospheres of distant exoplanets, sniffing for oxygen, methane, or other signs of life. One day, perhaps, we may point to a star and say, there is another world with oceans, clouds, and maybe even voices. But even if we never find another life form, the journey itself is enough. For what astronomy has given us is not only knowledge of stars and galaxies, but perspective. We know now that Earth is not the center of the cosmos, but a fragile world, one among billions. That realization carries responsibility to protect it, to cherish it, to understand that in all the vastness we have seen, this small blue sphere is the only home we know. From ziggurats to pyramids, from Greek scrolls to Arabic manuscripts, from Galileo's telescope to the James Webb Space Telescope, the story of astronomy has been one long gaze upward. Every discovery builds on those before, a chain of wonder stretching across millennia. And in the silence of the night sky, if you listen closely, you can still hear the echoes of ancient astronomers whispering, their questions now ours, their dreams now our journey. So when you step outside tonight, look up. The same stars that guided farmers in Egypt, sailors in Greece, scholars in Baghdad, and scientists in Europe now shine over you. They are ancient, eternal, unblinking witnesses to humanity's endless quest. Watching them, we are reminded that we too are stardust, children of the cosmos, reaching always for the light. The city of Pisa was quiet in the night air, narrow streets wrapped in shadow, the great tower looming over the square. A young student named Galileo Galilei, restless and curious, walked under the moonlight. He had always been haunted by questions, questions that refused to leave him. The stars above were beautiful, yes, but they were also mysterious. And mystery was something Galileo could never ignore. Even as a boy, he had wondered why lamps swung in cathedrals with a rhythm so steady it seemed eternal, why bodies fell to the ground as they did, why the heavens sparkled in perfection while earth felt so imperfect. Years later, when word spread of a new invention in Holland, an arrangement of glass lenses in a tube that could make distant things appear closer, Galileo's heart raced. He did not merely want to see through one, he wanted to build one, with patience and precision, grinding glass and fixing it into wooden frames. He constructed a device unlike any that Italy had seen before. And then, one evening, he lifted it to the sky. What he saw would forever change the story of the stars. The moon, once thought a smooth, perfect sphere, appeared rough, jagged, scarred with mountains and valleys. Its surface was not divine crystal, but stone, broken and real, a place not unlike Earth. Then, turning the telescope toward Jupiter, he saw tiny points of light, invisible to the naked eye, moving night by night. At first, he thought they were stars, but they moved with the giant planet orbiting it, moons of Jupiter, a shocking discovery. For if these moons could circle Jupiter, then not everything circled Earth. The old order of the cosmos was beginning to crack. Galileo's heart pounded. He kept watching, night after night, sketching carefully, noting every movement. The heavens were no longer fixed, they were alive with motion. He looked next at Venus and saw it changing in phases, just like the moon. Such a thing could only be explained if Venus circled the sun. Suddenly, the old Ptolemaic model, with Earth at the center, no longer made sense. The heliocentric vision of Copernicus, long dismissed, now burned with truth through Galileo's lens. But truth was dangerous. To question Earth's place at the center of the cosmos was to question centuries of teaching, to challenge not just scholars, but the church itself. Galileo knew this, yet his excitement overpowered his fear. He published his Starry Messenger in 1610, a book filled with his sketches and observations, a trumpet blast announcing that the universe was not as people had been taught to believe. His words spread quickly, stirring wonder, admiration, and alarm. In Florence, the Medici family, rulers of Tuscany, saw opportunity. Galileo dedicated his discoveries to them, naming Jupiter's moons the Medicean stars. In return, they offered him patronage, protection, and prestige. Galileo, once a professor of mathematics, became court philosopher and mathematician, his name echoing across Europe. Yet, with fame came scrutiny. His enemies multiplied, whispering in corners, warning that he had gone too far. Still, Galileo pressed on. He studied the sun itself, daring to stare at it through smoked glass, recording the drifting blemishes that moved across its surface. Sunspots, another sign that the heavens were not perfect and unchanging, but flawed, restless, evolving. He turned his telescope to Saturn and saw strange shapes flanking it, though his lenses were not strong enough to reveal the rings clearly. He looked at the Milky Way, that hazy river of light, and found it was made of countless stars, so many they could never be numbered. The universe, it seemed, was far vaster than anyone had dreamed. But every discovery widened the gap between Galileo and the guardians of tradition. The Aristotelian scholars clung to the belief in perfect spheres and heavenly harmony, unwilling to admit cracks in the old order. The theologians worried that moving Earth from the center of creation would move humanity from its privileged place in God's design. To them, Galileo's telescope was not an instrument of truth, but a threat to the foundation of faith. Galileo was not timid in reply. He argued with sharp words, mocking those who refused to look through the telescope themselves. "It is like refusing to use your eyes," he said, exasperated. His confidence, his sarcasm, his refusal to bow quietly made him both admired and despised. Letters flew across Italy, disputes grew heated, and soon the church itself began to take notice. Yet even then, Galileo believed he could persuade. He wrote dialogues, setting up conversations between characters that debated the old geocentric model and the new heliocentric one. He presented arguments with wit and clarity, leading readers toward the conclusion that Earth was not the center. His works spread widely, read not only by scholars but by ordinary people hungry for new visions of the cosmos. But power does not yield easily. In Rome, the guardians of orthodoxy summoned him. The telescope might reveal mountains on the moon and moons around Jupiter. They admitted, but to claim that Earth moved around the sun was another matter entirely. That touched scripture, tradition, and authority. Galileo was warned, gently at first, to tread carefully. He promised to obey, but his restless mind could not stay silent. For how could he deny what his own eyes had seen? How could he suppress the truth when the heavens themselves whispered it every night? He was caught between wonder and obedience, between discovery and survival, and in his heart he already knew which side would win. In the years that followed, Galileo's fame reached its height, but so too did the danger. Friends cautioned him, enemies sharpened their words, and the church grew less patient. The stage was set for confrontation. The story of Galileo and the stars was no longer just about science. It was about courage, defiance, and the price of seeking truth in a world not ready to accept it. Under the vaulted ceilings of Rome, Galileo stood before the Inquisition, his heart pounding as heavily as the bells of the cathedrals outside. The man who had once dared to measure the heavens now found himself measured by judges, cloaked not in stars, but in authority and fear. His dialogue concerning the two chief world systems had been too bold, too sharp. In it, the defender of Earth-centered views had been made to sound foolish, while the champion of the sun-centered model spoke with reason and clarity. To Galileo's critics, this was mockery, even insult, directed at the very church. They pressed him to confess. Did he truly believe Earth moved? Did he truly hold that the sun, not Earth, stood at the center? The evidence of his telescope, the logic of his mind, all cried yes, but his life, his freedom, demanded silence. With trembling lips, he recanted, declaring that he would no longer teach the Copernican model. The words were written, the signature placed, yet in his heart the stars still burned with the truth, and legend whispers that as he rose, he muttered, "E persim move," and yet it moves. Punishment followed, not death, but a quieter prison, house arrest. Galileo was confined to his villa in Arcetri, forbidden to teach his dangerous ideas. The telescope that had once carried his vision to the heavens now stood idle. Still, his mind refused to be caged. Blindness crept upon him in his later years. Yet he dictated his thoughts to devoted students, working on mechanics, motion, and the mathematics of falling bodies. Even in confinement, his brilliance glowed. The world moved on. His name became both warning and inspiration. Some saw him as a rebel, punished for arrogance, others as a martyr of reason. But time has its own justice. The church that silenced him could not silence the heavens. The evidence grew overwhelming: planets, comets, moons, the shifting skies themselves. Copernicus's model, defended by Galileo, became the foundation of modern astronomy. What had once been heresy became accepted fact. Centuries later, the irony was complete. The Vatican built its own observatories, its own telescopes pointed skyward, its own priests studying galaxies and stars. Galileo's trial, once a scar of defiance, now stood as a symbol of how dangerous and how unstoppable truth can be. And so Galileo's legacy was sealed. He was not just the man who looked through a telescope. He was the man who refused to look away. He saw mountains on the moon, moons around Jupiter, phases of Venus, sunspots drifting across the solar fire. But above all, he saw that truth is larger than fear, and that the stars do not bend to authority. They shine for those brave enough to see them.